Hello and welcome back to my channel. Students, in this problem series, we are trying to learn organic chemistry through problems. And in this process, we are currently focusing on a very important topic, stereoisomerism. So now let us see question number 32. In our present question, as you can see, we have 4 options. Each option carries 2 Fisher's projection. You have to tell whether both Fisher projection represents the same compound, the same configuration or not. So we will see it one by one, and before we have proceeded to answer it finally, let us learn about a few very important rules regarding Fisher's projection. Before you have started doing manipulation with a Fisher projection without changing its configuration, you have to keep certain things in your mind. First of all, while you are manipulating a Fisher's projection and keeping the configuration intact, you should not take it out of the plane of paper. Anything you should do, either rotation you have to perform or swapping of groups you have to perform. You have to keep the things on the plane of paper itself. The next thing, you can rotate the Fisher's projection formula by 180 degree, either clockwise or anti-clockwise. You should not rotate the Fisher's projection in odd multiples of 90 degree. For an example, 1 into 90 degree, 3 into 90 degree, 5 into 90 degree. Such rotations are not allowed. Anything you have to do, you can rotate the Fisher's projection formula by even multiple of 90 degree, that is the multiples of 180 degree. So you should understand, if you do so, the configuration will not change. The next thing is, with a chiral carbon, if there is a chiral carbon, you can swap the groups associated with that chiral carbon even number of times. For an example, you can swap 2 times, 4 times, 6 times, 8 times, and it will keep the configuration intact and will not change the configuration. However, if you do the swapping of groups odd number of times, for an example 1 time, 3 time, 5 time, it will change the configuration of that chiral carbon, and it should not happen if it has to represent the same compound, the same configuration. Now let us come to our option number A. In the option number A, as you can see, we have a Fisher projection, and these two are to be checked whether they represent the same configuration or not. Now, I will first do 2 swappings associated with this chiral carbon and will let you know that these two are same configuration. Now, what you have to do first, you swap this methyl group and iodine group. So there is a swapping 1 times. Once you do this, you will obtain this result. Hydrogen, iodine will come here, methyl will come here, and chlorine will come here. Now you swap the 2 groups, iodine and chlorine. You can choose any 2 groups. You should remember, you can choose any 2 groups. So this is the swapping you have done first time, and then you do the swapping of these 2 groups second time. So once you swap these 2, you will obtain this particular Fisher formula. So you have understood that you have done the swapping associated with this chiral carbon even number of times, that is 2 times, and if you do the swapping even number of times, the configuration does not change and it remains the same. So both represents the same configuration. So A is our correct option. Now coming on to option number B. So the first thing I have done, so you have to check about these two Fisher's formula, whether they represent the same compound, the same configuration or not. First I have rotated this by 180 degree, and you know I have already told you rotating by 180 degree does not change the configuration. So I have rotated it 180 degree, and I have obtained this configuration. After I have obtained this configuration, the next thing I did is I have taken this particular chiral carbon, and with this chiral carbon I have done swapping 2 times. What I have done? First I have swapped OH and H. So once you swap these two groups, you will obtain this type of configuration. H will come here, OH will come here, Cl remains as it is, and here Br was there, Cl and hydrogen. The next I did, I swapped hydrogen and chlorine. So this is the second time. This is the first time I swapped, and the second time if I do the swapping of hydrogen and chlorine second time, I will obtain this particular configuration. So you understand, the swapping I did with this chiral carbon does not change the configuration associated with this carbon, because I have done it even number of times. So again it is same configuration, and you have not changed the configuration of this carbon, so it remains the same. So rotating by 180 degree does not do anything. Swapping the groups associated with the chiral carbon 2 times does not change the configuration. So above configuration is not changed, below configuration is not changed. So altogether these two are same configuration. So both are representing the same compound, the same configuration. So again B is a correct answer. Now coming on to the option number C. In the option number C, as you can understand, I have again 2 configuration in front of me. As you can see, there are 2 configurations. The first thing I did, I swapped the groups associated with this chiral carbon 2 times. What I did? First I swapped bromine and fluorine. First I swapped bromine and fluorine. Then you understand, the fluorine will come this way and the bromine will come this way. Next I swapped iodine and bromine. Second time. So bromine will come this way and iodine will come this way. So once you do that, you obtain this particular configuration, which is identical to this configuration, because you have done the swapping 2 number of times. So same configuration, and below you have not done anything, exactly same as it was. So both the carbons remains the same configuration. The next thing I did, I swapped the second carbon. You understand, I took the second carbon and associated with this second carbon, I swapped OH and hydrogen with each other. Once I did this, I obtained this configuration. And you understand, this configuration is same as on the right hand side, but this configuration is not same as the starting configuration. Why? Because once you swapped 1 times with the lower chiral carbon, the configuration changes because you have done the swapping odd number of times. You understand? Above carbon does not change its configuration. However, the below carbon has changed its configuration because you have swapped the groups odd number of times. So you understand, the starting configuration had 2 chiral carbons on the left hand side. On the right hand side again it has 2 chiral carbon, but the top did not change its configuration. However, the bottom chiral carbon changed its configuration. So these two does not represent the same configuration. On this ground you can say that C is not our correct option. Now coming on to option number D. In D option, as you can understand, now we have 3 chiral carbons in front of us. You have to tell whether these two are same or not. You just do rotation by 180 degree. You rotate it either clockwise or anti-clockwise. You will see that you will obtain this particular configuration. Again, you rotate this by 180 degree and you will obtain the right hand side Fisher projection. And as I have already told you, rotating by 180 degree does not change the configuration, and the configuration is retained, and so the D is a correct option. So if you now answer finally in front of you, now the answer is in front of you. A is correct one, B is correct one, C, the configuration changed at the lower carbon as we saw, and the D, both are representing again the same configuration. So that is how you have to follow the rules and regulations of the Fisher's projection formula, that you have to keep the formula right on the plane of paper. You cannot take it away. Second, you can rotate the Fisher's projection formula 180 degree clockwise or anti-clockwise. It will not change the configuration. Third thing, with a chiral carbon, if you swap the groups even number of times, then it will not change the configuration of that carbon. However, if you swap odd number of times, that is 1 times, 3 times, 5 times, then the configuration changes.